Today lecture topic is cloud computing security. Security is a very important thing whenever we are going to the cloud. Security itself is important. Our data security, our infrastructure security is important. But when we are moving our business out of our own premise or our own control, then the security becomes more important as well. So to address the different kind of security or security threats, security vulnerability, so the vulnerability security threat do exist even if we have our devices in on-premise or even the laptop I'm using to take the lectures that also has some security vulnerability and threat. So the cloud computing or cloud service provider also have some kind of security. So let's begin with some concept related to cloud security. So these are the few concepts like confidentiality, data should be confidential, integrity of the data, authenticity of the data, availability of the data, threat, what are the threats are there, what are the vulnerability are there, and risk, how to do risk assessment, the cloud computing, metrics for risk assessment, security. So those are things we will cover in today's session. So confidentiality is basically something which is if we send something to someone, let's say from our computer, we are accessing cloud service, and then whether our data was confidential. It's like we sent a letter, which is a sealed letter, and which we used to put the seal on the letter, and if the seal is broken, then we think like someone has read the letter. If seal is not broken, then it was assumed that people have not read it. So it is related to that, whether we are sending the data, if someone else has read it or not. Some unauthorized people have read it or not. So that is called confidentiality, and that means the access should be given to only people or someone else has not access during the data transfer and storage when we are doing with the cloud service. This point like confidentiality, integrity, and authenticity, and repudiation, non-repudiation, all this concept sometimes is intertangled, confusing, and appear like it mean the same thing. But in the cloud computing security or security way, they have a different meaning and they have a unique different meaning. So confidentiality means someone has not seen the data, who are not supposed to see it. Now integrity means that is the data who is the same what we sent, or has it been altered? Like if a post has been, it's like assume that letter post has been sent and the seal was there, but what if by some mechanism the seal was kept intact and the content inside the letter has been changed? So this figure explains this, like was this message altered by someone unauthorized before it has been received? So that is called integrity of the data. The data has to be remain same. With respect to cloud computing for data integrity, whether the data transferred is the data received. That means I transferred ABCD and it has to be received as ABCD, not like ABDC or ABED. So data has to be same, and it is very important. The integrity is very important in the data life cycle. So there is a life cycle of data like create, store, process, archive, and destroy. So in all the process, the integrity of the data has to be maintained, like data creation, data storage, data processing, and data archiving, and then also data deletion. Some other security concepts are like authenticity. Authenticity means something having been provided by an authorized source. That means if we get our data, like if we are accessing a certain website, right? If we check whether the locks are there or not, like if we, let's say, for example, here you see the Azure, there is a lock, and we see it has a certificate, right? We can see the digital certificate issued by the DigiCert organization, and DigiCert could be the Microsoft own organization. Some big companies can issue their own certificate, otherwise VeriSign is their usual. So that is called, authenticity. Means something we are getting from the authorized source. Then availability. That means it is accessible and usable during a particular period of time. If you say that data is available from 24/7, so it should be available 24/7. Or if it is available from 8 to 11, then it should be available from 8 to 11. So that means the availability, that it is accessible and usable during a particular time period. Then the threat. Threats means any potential security violation that can challenge the privacy or it can harm the organization. So that is called threat. Threat can be both software as well as hardware. So both can be considered as a threat. Then the vulnerability means weakness of the cloud computing system that can be exploited to cause the attack to the system. For example, one of the vulnerabilities that the login ID and password is shared. Okay, now the question is that why availability is the specific part of the security concept. So we are talking about cloud computing security, right? The cloud computing, the best way to make it secure is do not have any access to it. Like let's have a Schrodinger box, and that is completely closed from everywhere. Nothing can go in and nothing can go out. That is the most secure system we can think of. But we cannot live in that world. We live in the time that it has to be used. So it has to be made available. Now, when we provide availability, let's say my cloud service provider is saying that the service is available 99.9%. So while ensuring the availability, if there is a cloud security threat happen or something is not available, the service is not available. So that also play a role, like the people have to do a trade-off that something has to be available when some security measures are being deployed or some patch are being deployed, how to make the things available. So availability also become a concept of security. If something is completely not available, we can call it a completely secure. But if it is available for some time or most of the time, then that also become an important parameter to provide a security. So that's why the availability is a security concept. This is a very good question asked, because it's every other point is related to security, then why availability is something related to security. So let's, I should also send the email to the author who says availability is a security concept. Let me see what response I get from the authors of the book. Then the vulnerability is that any weakness which can be exploited. Like a simple weakness is that the user ID and password is very simple. The password is very simple. It can be hackable. So that is a vulnerability. If an organization using only a 3-digit password, then it is a very vulnerable. 3-digit can be easily predictable. And if they're only using numbers like 1, 2, 3, then it is highly vulnerable. So that can be the weakness. There are many other weaknesses are there. Then comes the risk. So risk means what is the possibility or probability of having a certain thing. Like when we say a threat is there or vulnerability is there, it can be hacked. So what is the possibility of getting hacked, or what is the probability of getting attacked by those weaknesses? Now, a system has to be available, and it has to be available from port 80, right? Port 80 means HTTP internet port. So if the internet port has to be open, so that particular thing, if it is open, then it is a vulnerable. But what is the probability of that port getting attacked? And if we are putting some security measure behind it, how much that security measure, later on we will see the case related to this port 80 concept. So how can, if some mechanism has been put in place to protect that port 80 vulnerability, then what is the probability that still risk is there because the port is at least open for certain tasks? So the risk is measured in terms of threat level. You have seen recent last year, because of COVID, certain country, even now, certain countries are going into orange, red, green, gray. That kind of colors are being given to different country where COVID cases are higher or lower. So similarly, those are called safety level threat, right, for a country. So in cloud computing, the risks are measured in terms of threat level, like it is a level 1 threat, level 2 threat, 3, 4. So there are different parameters and criteria are there. Later on, I will show a cloud computing matrix, which by the Cloud Computing Security Alliance, CCM. So there we will see that what are the different parameters they use it, and there are certain parameters which are exception, means very, very important. Some are important, some are average, some are okay, maybe do it, or it is optional kind of thing. So based on different metrics, threat level is calculated, or how many vulnerabilities are there. Based on that, even in Azure, if you go Azure Security, you can see that they provide a threat level of a particular subscription. How many threats are there? What and also this also suggests what to do about it. Then the security control mechanism and policies. So these are the things associated with counter measuring different threat and how to handle the authenticity, availability, or authenticity, integrity, confidentiality. So these are the different countermeasure and safeguard to support how to improve the security. So there are security policies are there, security mechanisms are there. Security policies are part of security control by which a system can be made secure as well as available. Now, next comes the threat agent. So what are there are many threat agents are there. We are discussing a few of them. There are 4 of them only we are discussing here. So one threat agent is anonymous attacker. So now this anonymous attacker means these people are non-trusted consumer, means someone who does not have cloud computing, like Azure subscription. Someone does not have, they are not consumer, or they are a free consumer, and they are trying to access the cloud without the permission. And typically they do it by using some software program or chatbots, something like that. And they launches the network level attack via the public network. So they avoid private network to get known. So these are the anonymous attacker. This attacker usually does not have an idea about what is the security policies in place in a particular network, or they know little about, almost nothing about what is there inside. So they are simply trying to hack, attack, or something of a particular service provider or particular network. So this kind of people, they use certain kind of software to attack. If you a good software which used to do this ethical hacking is called, one is called Kali Linux. There is a Linux version called Kali, Kali. So that is used to do the penetration testing, etc., for a particular network security. If any of you interested in ethical hacking or becoming an ethical hacker, then you will be know that there are many softwares are there. As far as I know, 74, 75 software I know which are being used to do different kind of network testing and hacking and getting access to someone's network. I have an interest in networking, and security is my interest area. So if you explore, you will know. Then there are malicious service agents. That means they try to intercept a particular network traffic and they divert that to another place. That means they try to intercept what traffic is coming and they divert to the network traffic flows within the cloud. So, and usually it is a program or a service agent, or they pretend to be a service agent with certain compromised logic. So this kind of service agents exist within the cloud. Like the cloud is a multi-tenant architecture or multi-tenant services, where one of the tenant has installed certain software which is trying to maliciously divert network traffic or certain kind of threat creation by being within the network. There are many various mechanisms are there in cloud, like Azure, Amazon, AWS, or Google. They have tons of security mechanisms, software, etc., etc. As you have seen in the video also, that if the lift door is open more than a certain second, then the threat level alarm is rang. So if they are doing that much just for the door, how much they will have internally, but still there are certain kind of threat has been observed, and this kind of service agents are known as malicious service agent because they have malicious intention to do certain kind of thing. Now the trusted attacker. Now trusted attacker exists, means they are the authorized cloud consumer with a legitimate credential, and with, like, if I am a Azure subscription consumer, so I am a cloud consumer of Azure, and I have authorized access to it. And after getting access to it, if I am trying to do certain kind of attack within the system, so that is called as trusted attacker. Then there is a malicious insider. That means ex-employee of a cloud computing. Like it is basically a human, which has admin access or special access. And if a disgruntled employee, like if an employee of Azure who is not happy with Azure and he has been working in data center, he has admin access or high-level access to the cloud servers, he may have tried to go berserk, and that is called malicious insider. To handle this kind of threat also, there are certain mechanism and certain guideline and protocols are there, like randomization of their timing, or changing the department, or changing the server access time to time, so that this kind of threat can be avoided. Then it is cloud security threats. So we saw the threat agents. Now we see what are the threats are there. So there are 5 threats I am discussing here. The basic threat is traffic eavesdropping, and this is like someone is just trying to just read the data, just making a copy of whatever data getting exchange between a cloud consumer and a cloud service. And this can happen with anything, like a normal user and a network. So any network information, if it is not encrypted, someone may try to, if copying, that is called eavesdropping. So it occurs when data being transferred to a cloud or within the cloud is passively intercepted by a service agent. That means they are not doing anything, no interaction. They're just trying to read it. and this kind of threat is very difficult to find, because they are not doing any kind of activity. They are just reading it and not sending any acknowledgement or anything, no interrupts happening. Most of the government agencies who are actually doing the monitoring or uh, uh, they do is they comes into the traffic eavesdropping. They silently listen to the what is happening in the internet. They are also a security threat. Then the malicious intermediary. So this kind of threat, what did they do? They actually altered the data. Means I was giving example of the letter, like letter, they opened it and they changed something and they kept the seal as it is. That is not known that it has been taken, changed. So that kind of threat is called malicious intermediary. So this, when the messages get interrupted and altered, and it will compromise the confidentiality and or integrity of the data. That means data someone got the access and data someone has changed it. So both access and change, confidentiality and integrity will be compromised with malicious insiders. So this is a cloud consumer, they send the data, there is a threat, malicious intermediary, what he or she does, that it change the data, or it does, maybe it's a software, it does change the data and then pass it. So that virtual server became compromised. It can add some kind of virus, bug, etc. inside it, and it goes to the virtual server. Now, denial of service. So this is a, I remember it's called DOS kind of thing, or DOS attack, if it is a security attack of denial of service type. Why I remember this kind of thing is that, so let me explain it, then I will tell you the story. So there is this cloud consumer who tried to access the cloud, and there is another cloud service consumer who somehow overloading the network, and because of that, this is an attacker. This cloud consumer A attacker trying to overload the network. Because of that, the cloud consumers B is not able to access the its own service. So it can be done by increasing the workload artificially. Network is overloaded with traffic to reduce its responsiveness. And because if, let's say, a server is able to handle only 100,000 requests every second or every minute, let's say, and if we make a bug or write a program which running at the speed of gigahertz, so it can do more than 100,000 network requests on this service. And since it is only meant to handle 100,000 per second and it is giving more than 100,000, then the other who are getting served with this will not be able to get served. So there will be dropout, the network misconnection, and the session expiry, all these things will happen. And so the story which I was telling is related to when I started doing studying computer science, 1999. First time saw the computer, get access to it, to the university, and at that time people had less knowledge. And whenever we start knowing computer, etc., the very common interest we get is, can we hack someone else's system? Can we get access to it? So those are the common things. So that time, one of my friend told me that, you see, we can actually attack a network by doing a ping service. If we ping means, many of you have done it. Ping. So you see what it is doing. It is only, I ping this by.org, and it only sent the bytes, 32 bytes of data it sent. I sent 32 byte and received 32 byte, and its TTL logic is there, and time it took 48 milliseconds. So let's say we have a software, and if I ping my this BioAI website more than certain amount of time, the server on which this is hosted can access, then this BioAI website will not be available. So this is a simple DOS attack. Most trusted service provider has a mechanism that this, if someone is getting beyond certain number of ping or some certain number of requests, then they are been not allowed to take a access. So DDoS is not nowadays common. It is difficult if it is not, but if it is still possible, DOS attack is still possible. Many government services also get affected with DOS attack. So, but this was something which we had tried to do with our network administrator to divide him from the access. So we simply ping his computer IP address, and he was having a difficulty getting access to us. So we were trying to tunnel the data to our computer. So the network bandwidth was limited. Like 2 Mbps connection was there for the whole university, and if we divert 1 Mbps or every data, then he will not have any access to it. So DOS is remind me of that story. Then insufficient authorization. This attack occurs like when an access is given to someone who is not supposed to get, like attacker get access erroneously, or the access is given with more access than what's supposed to be given. Like if to our Azure subscription, if I give an access to some user who with an admin access, and that person's not supposed to have an admin access, that person supposed to just do the go through the different colloquium, does not need an admin access. Now, if that credential I given to someone who not supposed to, and that person if do attacks, then that is called insufficient authorization. And this happened because the access is given to someone else, or more than required access is given to the person. Then there is a insufficient authorization. So the attacker pose as a other consumer. So the cloud consumer A has access to it. It is a authorized user and legal user. But this particular attacker pose as this and try to go in. So by this can do by somehow getting the user information, etc. And then after that, it can or getting a digital signature or authentication signature from this by hacking, or by due to some security threat this organization has, and it is able to get access to that. So that is called insufficient authorization. Then the virtualization attack. Virtualization attack means a cloud service is basically what? It is a virtualization platform they are providing. And they are giving this virtualization to multiple cloud consumers, and they have access to the resources of the service provider. Now, if one of the service provider try to manipulate with the hardware, like this is a user, but now he became the attacker. So he has access to it, and now it make the server he has access due to some vulnerability within the cloud service provider software, that he utilizes it and make the whole system unresponsive. So other tenants who are actually working on it will not be able to get access. And if more vulnerability is present in the cloud service provider, with one access, it can damage the whole data center access. But this kind of thing can happen. In past, some security mechanism was not there. So this kind of scenario can occur if the software which or the security mechanism which the cloud service providers are doing is insufficient or had a flaw. But this kind of risk is very virtualization attack. There is a side channel virtualization attack is there that I'm not discussing, but I'm just talking about virtualization attack. Risk of this is happening, though the amount of risk is low, but still possibilities are there. Now, additional considerations are there like fraud implementation. I said that if the implementation was flawed, the user ID and password can be guessed, or if more than required number of attempt is allowed to do the login and password. Let's say if if you nowadays you access, right? If you make more than 3 or 5 attempts, your account get locked. Earlier, 5-10 years ago, you can do as many login and password failure means. So if, and people used to deploy the software, and that software is keep on guessing and guessing and guessing the password, and the hacking was happening. So nowadays that restriction has been done, 3 to 5 attempt only now most service provider provide. So this kind of be a flawed implementation that can cause the problem. And the security policy disparity, the security policies are not proper. There was the service level agreement contract is need to be considered as a security flaw in SLA, whether they have mentioned that they are going to provide the kind of security the companies are looking for or not. If the SLAs are not read well and it has not been mentioned about certain kind of security they will provide, then the contract itself can call. If it's not written, then you cannot go and sue the company, the cloud provider. Then the risk management. So to do the risk management, risk assessment, risk treatment, risk control. Cloud risk management is a very broad topic, and it require usually been done by very senior people in the company or people who are security expert or security advisor, or have done a lot of cloud computing security practices, audit and architecture like CCSP or CCSK, CCA. So one example control matrix I am showing you. If this is not a part of your syllabus, but I'm showing you, and not to, don't get too intimidated that what it is. Just for overview, I am showing you. So this is basically a cloud computing control matrix, right? How cloud compute control matrix are being used. So what are the guidelines are there? So if you go to this, right, there are different subjects are categories are there, like audit and assurance. Then this application interface and security, there are many points are there. And if we go the business continuity management, operation and resilience, then there's a change control, configuration management. Then if we go this data center and security. So if we go to data center and security, whether this data center, let's say the policies, are the policies and procedure for secure disposal of equipment used. So in data center, the hardware failure happened, right? So hardware failure happened, that means they have to dispose the servers or the hardware. So the policies, what are the policies there to securely dispose? So if some trouble happen in the cloud, and they are using the storage device, that storage device you simply cannot throw it because the storage device is not working. There are various mechanisms the data from the storage device can be taken. So, but before disposing, the data has to be damaged completely, and then the system has to be crushed without reconfigurable condition, and it has to be passed through the EM pulse, so to wipe off all the data inside it. All those security policies are in place or not. Whether secure disposal, if they are doing outside the organization premises, means if they have getting a third party to do it, whether they have the security policies to data, the the damaged hardware disposal is properly or not, and how often it is done, approved, or they have just started it, or it has been enforced, maintained. So this kind of then is a data destruction procedure applied? Means are they really using the data destruction procedure? So it should have yes and no, and based on all this yes and no, or 1, 2, 3, 4, how much they are doing it, the cloud security threat level or compliance get measured. If you go and see, a lot of things are there, and this is a job of a cloud security auditor or cloud security architecture. So in cloud computing security also, there are many specialization there, like a doctors. There are doctors for ear, nose, and throat. And even for ear, nose, and throat, there are subspecialization. Then there are doctors for bone, there are doctors for heart, doctor for brain. So even in the security of cloud, there are specializations are there. So this is for just to know, in the beginning level, someone don't have to do it. It is a job of someone with 10, 15 years of experience in the company, and that is also mostly a big company, a company size more than 50 to 100. They go through this if they are well certified, like CM level 5, 6, or that kind of certification. So this kind of, there are many other cloud related certifications are there. The companies are certified whether they are doing this kind of policy or not. So cloud, this is not a control matrix is not part of your syllabus. So it is just to show the overview. Then the cloud security, this is the last section. After this, I know you need a break. I have already taken 3:10. So this is the last part. Let's do it and finish it. Encryption. So this we are talking about what are the mechanisms to provide the cloud security. So one mechanism is encrypt the data. Means if a consumer sending the data, if it is encrypting it, then the service agent will not able to decrypt it if the message remain confidential and it goes to the cloud. So it is a mechanism by which the encryption is done. It preserves the confidentiality, that means no one has an access to it, and it also maintains the integrity of the data, that means no one can change the data. So this encryption is basically done by cipherizing the data with a key, and then it is transferred to the authorized user for the use. So authorized user will use the another key to get the data access. I forgot to complete the line. Now for encryption, there are two different kind of encryptions are there. One is symmetric encryption and other one is asymmetric encryption. So if the same key is used both for encrypting and decrypting, that means I used the same key. For example, I have one lock, and for that I have either a 2 key or the same 1 key, and I unlocked it and I transferred the box to someone with one mail, and then transfer the key to the same person with another mail, and if the same key is used to open it, so that is called symmetric key. Most of the internet services are actually symmetric key, like when we use HTTPS, etc. The security signatures are there. Those are symmetric key. Those are easy to do it. But then there are asymmetric key where a different keys. So there is a public key and there is a private keys are there. So used to do encryption. So public keys may be used to do encryption. And there's another key, private key is used to do decryption. So public key, why it is a public key? Because this key will be known to anyone who is trying to read the internet. So because this is sent publicly, the key is sent publicly. But the designated receiver will have a private key. With that only the person can open it. So this private key is a private one. So this kind of two different keys are used for encryption, that is called asymmetric encryption. So since two different keys are used and asymmetric encryption is more stronger, so it is a slower also. So because of this slowness, the symmetric keys are mostly used for internet activity. Asymmetric keys are used for some specialized purpose. So like you see, a data is being encrypted, then it become a ciphertext, and then it is decrypted, then it become a text. Now, if a data is there, it is encrypted with a public key, and then it is a ciphertext. It goes to there and used by a private key to make it back the data. Then hashing. In I think computer algorithm, if you study data structure algorithm, there you probably have studied hashing. Hashing is used basically one way, means it is a one-way irreversible form of data encryption. And some hashing techniques are known as MD5. Nowadays, MD5 is less used. There are SHA, CRC32, and there are many other different kind of hashing techniques are there, which are more stronger and stronger and stronger. So there are hashing technique if every computer is used to decrypt or find the encryption, then also it will take years to find what is the correct key which has been used to hash it. Normally, the hashing is used for storing a password. Basically, a message digest is there and which has been used hashing. And then this message is, since someone else, if you want to read it, won't be able to read it because it has been hashed. Now, digital signature is used as another mechanism to use to ensure authenticity of the data and integrity of the data. That means authenticity means it is coming from the user. It is saying that I am from this user. Let's say I am going to, I just checked, right, Azure service. So now if we go here and if we see it has a certificate, and you can see it is issued for Azure marketplace.microsoft.com. So we can go and see whether it is Azure marketplace.microsoft.com. That means this, and this is certificate issued by this person, and it is valid from this to this date, 1 year validity. So that means we can be okay that, okay, yeah, this is coming from the correct one. So the authenticity is being maintained like this way. And in this case, it is a non-repudiation. That means it cannot be challenged. The authenticity or the validity of the signature cannot be challenged. Both hashing and asymmetric key encryptions are used for creation of digital signature. So hashing and asymmetric encryption are being used to create the digital signature, and then websites are using that digital signature to show that they are the genuine person, and that digital signature are used to create a session key to get access to the server and maintain the connectivity for longer period of time. Now all this security etc. has to be managed by something. So the way or the protocol which manages this asymmetric key, that is known as public key infrastructure. You have different kind of private key, public key. It has to go and it has to there. So all this digital signature. So this all is known as public key infrastructure, and this has a protocol, format, rules, practices, and to show that large-scale system can securely use the cryptography, the public key cryptography. Then identity access management. It is comprises of component and policy necessary to control and track user identity. So even the UIT, we have IAM, the identity access management, by which the authentication, authorization, user management, and credential management can be done. So IAM, you can explore more about IAM from Azure Marketplace IAM. If you go to so if you go Azure Marketplace IAM, So you can explore more about what IAM means. They have a documentation, etc., etc. So you can read about them here if you want to know more about it. So that is the Azure IAM, but the IAM is a general concept. Then single sign-on, UIT also uses a single sign-on. That means when we are trying to access multiple cloud services and you just want one user ID to be used across different cloud services, then a single sign-on is used. Like we are using a FIDE login or some kind of login mechanism by which we can, with using the FIDE login, I'm able to access the UIT own internal management system, and the same FIDE login I am using to access the Azure marketplace or any other or any government services or anything. So that is done using the single sign-on technology. So it is an authentication scheme that allows user to log in with a single ID and password, and it is useful when the cloud service consumer need access to cloud services residing on a different cloud. This single sign-on came during the 2000s time, when lots of things require, and everywhere you need a user ID and password. And every time you are entering user ID and password, the process was becoming cumbersome, and it was not becoming speed, because there are many softwares are there and one is dependent on other, but they all maintaining the integrity by having the authentication, etc. But if one software accessing the software 2 and the software 2 accessing the software 3, and every time the authentication is needed, then it was becoming a headache. So the technology came, or protocol came, authentication scheme came, which is called single sign-on, that helps with one access can access many different type of services, and that is also applicable to multiple cloud. This is the last one, hardened virtual server images. Now, you have seen like template, right? Now we can create a template and we can create what virtual network to use, what port to open, and what other security to use, what software to be installed. So like that, templates are used to create the virtual server. Now, many times we are using the same template for creating virtual server, but not all tasks require everything. So what if we are not using anything which is not needed? If you are keeping something which is not needed, and that can bring the security threats. So hardening is a process of stripping unnecessary software from a system to limit the potential vulnerability. That means that can be exploited by attackers. So redundant programs, redundant ports to be closed, redundant services, like the services which is not being used for that particular VM task should be disabled. Like you see, close unused unnecessary port, disable unnecessary services, disable root access, disable guest account from the directory, uninstall redundant software, establish a memory quota, provide a certain quota of a memory, so that more than that, if it is using, we will know that some wrong had happened. Otherwise, if more memory quota is given, then additional software which is a malicious can stay there and can do the attack. So this is known as hardened virtual server images. And so it's better to decide what is needed. If some ports, there are so many ports are there, and if it is only internet port is needed, then just keep the port number 80 to be open. If it is file transfer only is needed, then keep the port number 20, or if it FTPS is needed, then keep the port number 21 to be open. And if it RDP is needed, port number 22. We may close every other port. Then that will make the system more secure. With this, thank you. If you have any questions,